Able to hear me? Yes, guys, am I audible to all? Okay. So, yeah, Vishnu, you can ask your question.
Ma'am, actually, this is Abhijit asked me, but this is like a question from the time complexity.
Mm-hmm.
Uh, Question number 4.
Okay.
I mean, I really liked his thing. That's why I'm bringing it up.
I'll just.
Yeah, yeah, sure.
Yeah, you can ask now.
So what you're saying is right. The sum of n times is a geometric progression,
Mm-hmm.
and but the number of times the counter, the loop is running
Mm-hmm.
is log n times. So I
Uh,
ran it with scenarios of 5, 6, and 10, 100,000.
mm-hmm.
It's log to the base, log n to the base 2.
Can you come again? I didn't get you what you're trying to say actually.
Yeah, yeah, yeah. So in order to make it simple, can you just cross a plus minus? So below this while loop,
Mm-hmm.
a plus equal to I. This is like not required, but the thing is that the uh, loop, how many times it is going, is log n to the base 2. That's what I observed when I run it in IDE.
Did you checked it for like 10 to the power 9 value?
Uh, Actually, my system has low memory. I tested for 1000, 110.
Try to check it for okay, login for 1000 will be like approximately 2 to the power 10.
Oh, okay.
Okay, it works, but like I want you all to check this particular function for like bigger values, like let's say 10 to the power 9, and then tell me like how many times it is actually running.
So yeah, I ran for 10 to the power 9 and it runs for 30 times.
Okay.
So
Okay,
mm,
that's amazing. Let me just check it once. So what was the observation? Can you tell me that?
yeah, so the sum of n by 2, n by 4, n by 8, what you have said is 100% correct. But the
Correct.
number of times the counter runs, the loop runs,
Mm-hmm.
mm, like for example, if
It is
we,
actually running for login, right?
yeah, yeah, instead of a plus equal to I, if you just do a plus plus, that will give me how many times the loop is running. So
Oh, okay, okay, I got it. So it's
so
a.
yeah, if you just make it a plus plus, then it shows me that number of times the counter is running,
Okay,
and that matches with the log n times the uh, number of
got
counter.
it.
Yeah,
Got it. Yeah. So you all can like change your observation here and you can write it as login.
correct.
And like knowing this, you all can like, but like when you will be proving it in a, you can say the formula basis, like I have did it in terms of the GP, it will come out to be order of n only. So please keep that in mind, and like don't just say that it is login in front of anyone like interviewer, because you can't prove it as of now. Okay, but if he or she asks you like, are you sure is it going to be order of n only, don't you think that it can be less than that, then you can say that yeah, probably, because big O gives you the like worst time case complexity. But here you can say, I think according to my observation it will be lesser. Clear?
Yeah.
Yeah. So yeah, anyone else having any other doubt? And good, Abhijit, the observation was great.
Ma'am, in question number 4, what will be the final answer?
As per what Vishnu pointed out, the final answer is going to be login. Okay.
Thank you.
Yeah, so let's focus on our today's session. Okay, so here I will take your n equals to 100. It is nothing but you can say the array which I am taking right now, which is of size 100. Now, I'm giving you some scenarios. I am pushing 60 items into the array. Where will be your top? If I am pushing 60 elements into an array, like into the stack, so where will be your top? The initial position of the top, if you want to know, the initial position of top is -1. I am asking the exact position. I am not asking which element it will be at. Just give me the position or the index of the array. It will be 59 after the insertion of these many elements. Vishnu, how come it can be this much? -1.
No, I am thinking that uh, every time we do the pull, it will move from -1 to the last element. I don't know, but I'm thinking like when we are pulling. Uh,
No, come again. What you are saying?
so my understanding is stack is a technique to get the last element.
Mm-hmm.
So uh, from the top, like from the up, I will see the last element, and pull will just move the counter from -1 to 0.
What is this pull? I'm asking about the push operation.
Oh, so when we are saying that the top element, so we are telling about the last element, first element which was pushed.
You know that there is only single pointer in the stack, that is top. When you insert the element or when you take out the element, when you insert, top is incremented. When you remove, top is decremented.
Oh, I got it now. Yeah, I forgot that there were one count. There's one count.
Yeah. So answer accordingly. Okay. So if it is the 60th element and you know that an array starts with 0 indexing, so the position of your 60th element will be at 59. Clear? This is your top position. Next is what will be the size of your stack? It will be 60. Good. Now next is if I am popping, I am talking about the same array, huh? I am popping out 40 elements. So how many, like where will be your top element now? Where will be your top pointer? 19 index, correct. What will be the size? 20. Third situation, I am again pushing 70 more elements. So what will be the top elements indexing. '89. And what will be the size? 90. Good. Coming on to our Q part. Let's suppose I am performing an NQ operation on the same type of situation. Your array is having the size of 100. I am inserting 60 elements. Okay, I'm NQing 60 elements. So where will be your rear pointer? Where will be your front pointer? And what will be the size? Guys, be quick and tell me. Rear will be at 59. As I told you, if you insert any element, just make this as 0. And size here will be 60. Vishnu, yesterday I told that as soon as you guys insert even one element into your queue, you have to make your front equals to 0. Remember? Okay, now talking about the DQ. I am DQing. Just a minute. I'm DQing 20 elements. Where will be your rear? Where will be your front? Sorry, don't just make it as 20. Make it the same way, 40. Yeah. Now tell me where will be your rear? Where will be your front? Guys, front pointer is for removing. Okay. So if you start removing from first, it will reach 39 by the end. Yes or no? Not even 39. It will be at 40. Everyone, are you able to follow this? After removing all the 40 elements from 0 till 39, your front pointer will be at 40. No? Next is rear pointer will remain at the same position, that is 59, and size will be 20. Again, I am trying to insert 70 elements. Is it possible to insert 70 elements? Now see this in this way. You have your queue. This is, let's suppose 40. This is your front. This is your rear at 59. Your array length is of 100. Remaining elements here are, what can I say, 41. You have to insert 70 elements. How can you insert?
Ma'am, but queues are dynamic. They shouldn't grow, no? They should grow.
But queues are dynamic. That's a different thing. I am saying you that whatever space I'm giving you, you have to accommodate your queue in that particular space.
Okay, then it will not. Yeah. Yeah.
You only have like, you can see that this much space is also empty of your queue, right? But you cannot enter your elements here. because your rear and front have already moved. Only this much space is available. And when you try to insert more elements, you will get array index out of bound. Clear? Is it clear, guys? To solve this concept or to solve this problem, because we can see we have empty spaces, but we cannot use it. The concept of circular queue came. The concept of circular queue was that if the queue is filled, check once that whether there is an empty space at the start or not. If there are empty spaces, you can use them. Otherwise, then you can throw this error. Clear?
Ma'am, I have one question.
Mhm.
Can I put 101 elements in a circular queue, or will it
Any?
overwrite?
No, you just tell me, can you?
Uh, yes, if we can overwrite.
But just tell me that you have a space to accommodate 100 people and all of them want the ticket for the particular concert and 101th person is coming to you. Will you like override one of the person from that 100 people queue?
No, in real life, no, but in
No.
arrays, we can overwrite.
But see, we can only override the number if and only if it has been popped out or it has been like deleted. Okay.
Oh,
If it has not been deleted, how can you override it? It's, you can say that it's generally like it should not be done. Otherwise, it will like corrupt your data.
right.
Okay.
Got it.
Okay. What about the, yeah. So what about the rear? You can see here that ultimately rear pointer will reach this 99th index. Yes or no? Let's imagine your front is still here. Okay. So we just check if front is still equal 0. If it is equals to 0, it indicates that your queue is full. But if it is not equal 0, it has moved ahead, then we just like make our r equal 0 and start inserting our elements from the start. Clear?
No,
Uh,
no. See, this you're telling in case of circular queue.
yeah, circular queue I'm saying.
So you mean to say that if front is in the first position, rear should not cross the front position.
Correct. If front is at 0
Yeah,
and rear is at the end,
yeah.
okay, then you can see that none of the element is deleted and all the elements in the queue has been filled. Then obviously your queue is full. You cannot enter any other element. But in case, let's suppose, I'll just make your this much queue is filled and this much is empty. In that case, your front is here, your rear is here. So you will check if your f is equal 0. If it is equal 0, then no worries, it is full. But if it is not equals to 0, in that case, you will reinitialize your r equals to -1 and again start your push operation. Clear? I guess it was the doubt of Kishan. Kishan, is it clear to you? Kishan, did you get this point that it will check if f is not equals to 0? Okay. How will you get to know that your queue is empty or not? Like your queue is having the deleted elements or not? How you are going to check that? Can you unmute and tell me how you will check that? By checking rear and front. What will be the role of rear and what will be the role of front? Okay, no worries. You can just keep on chatting. That will be fine. Can you tell me what will be the role of rear and what will be the role of front? front for removal. So if front is ahead of 0, that means there are some elements removed, right? So if we are checking if front is not equals to 0, it means we want to know if your queue has removed few elements or not. If this condition is true, this means that you can insert the elements from the front also. In that case, you have to reinitialize your rear equals to -1 so that you can again continue your push up like NQ operations as it is. That was the only logic. Clear? Kishan, are you still in the doubt? Yeah, so in that case, we need to queue from this. Yeah, we need to insert the elements from the starting. Anyone else in the class having any other doubts?
Ma'am, one doubt I have,
Yeah,
what my understanding is that if it is all blank, the stack is blank, array is blank, the first time when we add, the rear and front both pointer move by one step.
you're talking about queue.
Yeah, Q.
Yeah, okay.
Now, once it has crossed the 100 limit, the rear should go back to 0 instead of -1. Why? Because like it will fill from the 0. Because if we reinitialize to -1, I will still think that it's blank, like everything is
Yeah,
empty.
so that can also be done. See, empty is only the case when your front is also -1 and your rear is also -1.
Yeah.
Okay. And now what you were talking, we can also do that. You can see that if your array is of 100 size, the indexing will be up to 0 till 99. Yes
99.
or no?
Yes.
Yes. If I add rear one more, like let's suppose your rear was at 99, I add 1 to it. What will it become? 100.
Yes.
Can it be inserted like 100 index is present?
No, no.
No. Where should we insert this 100th element if your
0.
queue is empty?
0.
0. For that, we have a formula. You did r plus 1. Now the size has become greater than your array size. To
Yeah.
make it equal to the array size, we will do its modulus by n.
Okay.
Clear?
Got it.
Everyone, do you know this formula? As soon as your indexing is starting to get out of bound from the array size, you just do modulus n. What this modulus will do, it will give you the numbers which are within the limits of your array. Clear? For example, if your R was, let's suppose, 99, okay? 99 plus 1, it became 100. Your n value or the size of the array is also 100. Dividing both of them, we will get the modulus as 0. So it will go to 0th index. Clear?
Ma'am, one more. In these circumstances, when supposing R is at 1 and front is at 50, so in that case, the size would come out to -49 or absolute value of front minus rear.
We are coming to the size part, but for now, I want everyone to be clear with this rear thing. Are you clear with this formula, everyone? Okay, that's good. So yeah, you can follow either of the two ways. Either you can use this if condition and reinitialize your R, or the other way you can use this formula. This formula is more useful because you need not like reinitialize your R and all. So you can go ahead with this. R is equals to this. Following the DQ operation now, you only thought about inserting the numbers. Now let's suppose your like front reached here. Okay, and you have inserted elements from the starting also. How are you going to take your front back to the start? You have to take care for that also, no? By dq, that's right. But what will be the formula? Because right now what you were doing was f plus plus. But if you will try to do f plus plus at the end, if f is at 99, f will become 100. And there is no element at the 100th place. What will you do then? Yes, that's correct. Again, here the same formula will be used. That is f is equals to f plus 1 modulus n. Clear, everyone? How f came to 99? Richa, imagine the situation where you deleted further all the elements and reached till the end of the array. I'm talking about that situation. Okay. Now you are clear with your front and rear. Talking about the size, how are you going to get the size? Till now, when we were finding out the size, it was very simple, rear minus front. Now how it will come out to be? Everyone, are you able to follow this?
Hello.
Yes.
Yes, ma'am. I have one doubt in a last question that why
Yeah.
we are doing modules? What is the
Why
use of that?
why we are doing modulus?
Yes, yes.
Okay. Once your limit has extended beyond the size of the array. Okay.
Okay. Okay.
Like you have inserted up to the 99 elements and now you cannot insert further.
Okay.
Clear?
Yeah.
But there is an empty queue from the start because you have deleted the elements also.
Okay.
In that case, you can enter the elements in the queue, right?
Yes.
So for that, we have to like take our rear pointer from the end to the start.
Right.
Yeah. For that purpose, if you see, if it is at 99, if you will add one more element to it, what it will become?
100.
100. It is going beyond the size of the array, yes or no?
Yes.
Then if we do the modulus, what is the purpose of the modulus? If I do any number, like let's suppose 100, and I am modeling it with 9, what is the purpose of this modulus?
It will give us the remainder.
It will give us all the values between 0 till 8. Are you
Okay.
getting this? Like it sets the range. If I
Okay.
do the modulus with, let's suppose, 11, then it gives me all the values between 0 till 10.
10.
Like it
Okay.
won't give me the modulus value beyond 10.
Okay.
Clear?
Okay.
It is very obvious now why anything is like giving you as a remainder, because it is not able to divide it completely, right?
Right.
Yeah. So when we use this formula r plus 1 modulus n, it is going to give you the numbers from the starting. That's it.
Okay.
That's why we are using the modulus thing. Clear?
Okay.
Same thing goes with the front also, because front is also going to reach the 99 limit and it has to again start from the starting point. And that's why we are following the same formula for the front also.
Okay.
Yes. Yes, guys, did anyone figured out about the size? I'm giving you a scenario here. Try to think and tell me the answer for that. Okay, I have got few suggestions. I'll just take all of them. N is equals to 10. I am imagining my front is at 9 and my rear is at like the starting and it is at 2. Okay. So if you do absolute of first formula, consider these as the indexes. Okay. Absolute of rear minus front. Vishnu, can you tell me the answer for this?
Madam, I think it should be 3 because it will be 1, 2 or 0, 1,
Yeah,
2.
no, what it should be is different. I'm asking according to the formula which you told, what should be the answer?
Yeah, I'm wrong. 7, according to what I said.
Correct.
It should be.
No, it's perfectly fine to make mistakes. It's not a disheartening thing at all. I'm just because if we won't be wrong, then we won't be able to correct it also. I am not imagine this. You are here in this location. Here it is stored 1, 2, 3, and 4. These many elements are here, right? Others all are empty. Okay. Kishan, will you get your answer from this formula? I will again point it out. Here it is your rear. Here it is your front. Now, can anyone tell me? Till now, what formula we were using? We were using the formula R minus F. So if I will do R minus F here, I will get 2 minus 9, which is going to be minus 7. Yes or no? Is it the correct answer? Sorry, we were not doing R minus F. We are doing R minus F plus 1 also. So if I'll do plus 1 also, I am going to get here minus 6. But this is like this answer you have got when this particular rear has crossed the limit, right? So plus n can be added to it so that our rear pointer always stay in the positive end. Are you able to follow this? It's nothing but like you can say that rear start rotating. Okay. It was initially at 0, then 1, 2, 3, 4, 5, 6, 7, 8. Okay. When again it came back here, which element it should be? It should be the 9th element, right? 10th element, 11th element. It is like a cycle, right? So when you are like rotating in this rear, it should be like n added to it. Yes or no? Yeah. So that's exactly what our formula will consist of. You just add n to your formula. So it will be like R minus F 1 plus 1 plus n. Clear? All these things I have told you for the circular queue, okay?
Yeah, but ma'am, in this cycle, if we are having like 2, 3 times, then how many times we have moved, then it should be multiplied by that many times n.
How many times this cycle can actually continue?
Oh, I mean, from my perspective, it can go on forever. Like keep on increasing our, no, it will be only 1. Okay.
It will
It
be
will not
only one
cross F.
because,
Yeah.
yeah,
It will never cross F. Yeah. Yeah,
got
got it.
it.
Yeah.
Everyone else, are you got it? Like, did you got it? Okay, that's good. Did you watch the videos yesterday for the sorting? Okay, Kishan watched, Bhuvnesh watched, Gaurav, no. Yeah, guys, be quick. Half of it. More people. Aman, no. Weber watched. Kalidas watched. Okay. Those who have not still watched, Ashish, if you are there on the Telegram group, the link is shared there. So those who watched yesterday, did you understood the concept of bubble sort and the insertion sort? Okay, 1 yes, 2, 3, 4. So guys, see, this is the advantage of, like, if I am telling you some, like, to study some topic before ahead, then you will be able to understand a concept in a more better way. Okay. Yeah, you can do that, but every one of you, I'm again reminding you all, just watch these video today, okay? Because it will be really helpful for you all in the sorting. Okay, then I'll just move on to the question. I'm giving you questions on stacks. You have been given an array, like a set of instructions for array. Okay. If I'm giving you the numbers, it is like you have to insert them into your stack. If I am giving you this function, gm, this means you have to give the maximum value among all the elements present in the stack. Like if I will run the greater max function now, I should be getting 5 as my answer. Then I will insert 10. Again, greater max function. Then I am popping out an element. Again, I want to use the greater max function. Then again, pop out the elements. Insert 1. And at the end, I am again wanting the greater max function to run. We will quickly do this so that we should know the answers. I inserted 3, 5, and -1. If I will run this greater max function, what will be the answer? 5. Now, again, I will enter 10, and now the greater max function. What will be the answer now? 10. Again, I will remove the element, okay? Just a minute. Yeah, this is popped out now. Now, what is the greater max element? Like maximum, get max element. 5 again. Okay. Now I'm popping out 2 elements, -1 and 5. And I am inserting 1. And I am now running this get max function. What will I get as my answer? 3. So you all are clear like what's happening in this particular particular question? Okay. How to do it using stack? Think of this particular question for a minute and then tell me what can be done. Okay, so I have two solutions. Top pointer has to be used in greater max or not. It has to be used, right? See, my question is that for getting the maximum element, what you are going to do? You are going to write another function, that's fine, but like you are going to iterate in the entire stack, right? To get the maximum element, yes or no? So imagine that all the times I am trying to run the greater max function, it is going to run for n times. That is the number of elements in your stack. Yes. So it is something unnecessary, right? Because we can just calculate our greater max function on the go. Let's say I have inserted 3. Okay. So for now, what is the maximum element in my stack? 3. I will maintain another stack with the maximum elements. Okay. Next is when I insert 5, what is the maximum element of my stack? 5. I will maintain 5 here. When I insert -1, what is the maximum element? 5 again. Now, if we want to find the greater max element, I will just return the top value of the another stack. Yes or no? Yes. Next is I am trying to insert 10. What is the maximum element in the stack now? 10. When I will run this greater max, like get max function, I will simply return the top value. Now, if I pop it out, when I'm popping any element out, then it should be removed completely. Okay. Like you have to remove it from the first stack as well as from the max stack as well. Okay. Clear? Let's just keep it. Now, after the popping out of the 10, what is the maximum element in your stack? You can simply give the top element again, right? Again, you have to pop out. So I'll just pop this and I will pop this element. Now I will try to insert 1. Let's suppose I'm inserting 1 here. What is the maximum element in your stack now? 3. If you will again run this get max function, what will you get as an answer? 3. So you all got it that even though we are using an extra space for another stack, we are trying to save our lot more iterations which are going to run up to n. Clear? So the places and one day one was asking now like what is space complexity? Space complexity is nothing but the extra space which you are going to take in your particular program. Clear? So if let's suppose I made a stack of order of n for the insertion of the elements and I made another stack for the maximum elements. Overall, we say that order of n plus order of n. Overall, we say that it is order of n space complexity. Clear? And here I am talking about the space complexity. Clear? Same goes with the time complexity also. It is also the order of n and order of n. Guys, are you clear? Okay, so how many of you will try to write the code for this particular program on their own?
In order to have the best solution, to have lesser space, we can run the max for all the elements in within this array, from where top until zeroth point of the array is. I mean,
Yeah,
it'll
but
add
that will
something to
take
time, extra time. Yeah.
that that's what we were discussing, right? Like for every grade, get max function, you are trying to run in the entire stack and find the maximum value, right?
Yeah.
Yeah, and that is going to consume more time, because let's suppose that in this entire like array elements, I gave you like only 2 elements for the insertion, and I gave you all the get max function.
Yeah.
So you will end up doing the same task of get max function again and again, right?
But it will save space.
But the place where you can like save your a lot of time by like giving a little extra space, you can take that chance.
Okay.
Okay.
Yeah. Yeah.
Because if you all know, we use many time hash set or hash map or tree set or tree map just to give us the ease of calculating the things, even though we know that it is going to consume a little time. So okay, I'll like leave this particular question to you all. Try to do it, otherwise we will try to implement it tomorrow, and then we will further see the questions of the stack. Clear? Everyone, are you clear?
So all we have to do is put them all in array and then write a pop and get max
No,
function.
no, 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 no. Try to find the like the what you can say the definition for stack in your Java or Python or whatever language you are using now. Like there will be a stack, right? So
Yeah.
try to use it, try to see what are the functions which can be used. So you will also explore stack. Okay.
Yeah. But all I have to do
Yeah.
is apply push and pop in this array.
Yeah, right. So you have to use the inbuilt functionalities, because I'm pretty sure many of you must not have even used stack so far in your like day-to-day life, like in your work and all. Yes, Bhuvnesh, I'm trying to say that only. Use the Java stack class.
So is a greater max function there, or we have to override the greater max function in Java?
Greater max function, so you have to write. That
Okay,
is not
got
there.
it.
Okay, then, guys, thank you for today's session, and I'll just end the class today. And
Ma'am,
we will, yeah.
share the link, web link of this
Oh,
whiteboard.
yeah, yeah, yeah. Thank you. Thank you for that. Yeah.
Okay, thank you so much.
Okay, then have a nice day, everyone, and we will meet tomorrow. Bye.